Welcome to the deep dive. Okay, so we all kind of know computers run on zeros and ones, right? But have you ever stopped to really think why? Why that specific simplicity? Today, we're diving deep into binary. It's not just some tech detail, it's, well, the secret language behind everything digital.
It really is. And it's fascinating because it's not just that things are built on binary. It's how this incredibly simple foundation allows for such mind-boggling complexity. We're talking weather prediction,
Yeah.
huge virtual worlds, all from zeros and ones. It's kind of the ultimate less is more.
Right. So binary, just two digits, 0 and 1. That's it. We humans, we use decimal, 0 through 9, probably, the whole 10 fingers thing. But computers, no fingers. So why are they stuck with just two options? What's the deal there?
That's the core question, really.
Hmm.
And the answer. It's deep in the hardware. Inside every computer, you've got billions of these microscopic electrical switches. They're called transistors. Think of them as tiny, tiny light switches. But switches that can flip on or off billions of times every second. It's incredibly fast.
Okay, tiny switches, on, off. That maps perfectly to 1 and 0. I get that.
Huh.
But why couldn't they, I don't know, design fancier switches, switches with maybe 10 levels for our 0 to 9?
Well, that's where reliability comes in. It's much, much easier for electronics to reliably detect just two distinct states. Is there electricity flowing? That's on, a
Yeah.
1. Or is there no electricity? That's off, a 0. Trying to accurately detect, say, 10 slightly different voltage levels.
Billions of times a second.
Exactly. Without errors. That's incredibly difficult and prone to mistakes. So this simple, robust on or off nature of transistors makes binary the perfect, most reliable language for the physical hardware.
Okay, that makes a lot of sense. Fewer states mean fewer chances for errors, especially at those speeds. So if it all comes down to just on or off, 1 or 0, what does the computer do with them? How do you get from billions of simple ons and offs to, like, a complex video game or streaming a movie?
Right. So everything inside the computer gets translated into patterns of these zeros and ones. Your text messages, photos, the music you stream, even the computer's own instructions for its brain, the CPU. It's all binary. Take letters, for instance. When you type H, the computer doesn't store an H.
It stores numbers.
First, yes, it uses a code, like ASCII or Unicode, which are basically dictionaries assigning a unique number to every letter, symbol, emoji, everything. So H becomes a number, maybe 72, and then that number 72 is converted into its binary equivalent.
Which is a specific string of zeros and ones, like 0101001.
Exactly like that. And the letter I would be another binary string, 011010001. Put them together, you get hi, images. They become binary data, describing each tiny dot or pixel. Videos are just sequences of those image instructions. It's kind of like a universal digital Morse code running incredibly fast.
Wow, so it's not just storing things this way. The computer actually thinks in binary, too. It does the math with zeros and ones. That sounds really basic for complex calculations.
It is basic, and that's the beauty. All calculations happen using binary math. It's simpler than our decimal math. For example, in binary, 1 plus 1 doesn't equal 2, it equals 10.
Which means 2 in binary, right? 1, 2, and 0 ones.
Precisely. And 1 plus 0 is 1, 0 plus 0 is 0. Super simple rules. This means that computer circuits for doing math can be incredibly simple, fast, and again, reliable. No need for complex decimal calculators inside.
Okay, pulling it all together then, what's the big picture? Why is binary the foundation?
Well, it really boils down to a few key things we've touched on. First, hardware friendliness. It perfectly matches those billions of tiny on-off transistor switches. It's just a natural fit. Second, reliability and simplicity. Detecting just two states is way easier and less error-prone for electronics. Super important. And third, universality. This simple system can represent everything: text, images, sounds, instructions. It's a common language for all data.
Fundamentally, it's the most basic language possible for the hardware.
Exactly. It's the simplest, most stable way for the physical parts of a computer to handle any kind of information. So yeah, every app, every website, every game you interact with deep down, it's all running on those fundamental zeros and ones.
So this whole deep dive gives you a new way to see your screen, doesn't it? Knowing that hidden world underneath.
It absolutely does. And maybe a final thought to leave you with. Just think about it. This incredibly simple on-off, yes-no system builds the unbelievably rich and complex digital world we experience. Makes you wonder, doesn't it? What other seemingly simple building blocks might be powering things all around us in ways we don't even realize?